Just a quick video to explain a little experiment or a little project I'm using a microbit for. First of all, I'd like to just show how I've connected up the wires to the microbit. The microbit on the port 0, 1 or pin 0, 1, 2, 3 and the 1, 1, 2, 5 volt and ground. They've got holes through, so you can kind of put a little nut and bolt through there. And I've just got these little terminals on there, and I've bolted them down with a short M3 stainless steel screw, a little washer on the back. I've used these crimp terminals and then reclaimed a little bit of cable from a bit of 3-core cable, and then just a bit of red and black. And then I've put these little bootlace crimps on the ends. And then I'm using these Wago connectors for very simple projects like this. One problem with using breadboard is the pins are quite fragile, and if you keep moving the pins in and out of the sockets on the breadboard, they can break, and sometimes the connections are quite poor, so it's not that reliable. And if you've got something a little bit more complex, you want it to be quite robust, otherwise there can be a number of problems, problems with the coding, or problems with the connection to the microbit, even problems with the microbit itself. When I was setting these up, these are from 2015, and the firmware needed to be updated, and they wouldn't work with web USB through Google Chrome either. So what I've got here, it's just a potentiometer, and I've got this to plot a little graph on the little LED display on the microbit. So if you turn the pot up, you can see it's pulsing a little bit, but these LEDs are actually steady. So that's all the LEDs illuminated, so that's with its one direction. If I rotate it all the way across, you just got the one LED just lighting up there. So it plots a little graph, and then you've got every sort of position in between. So what I've done here, I've programmed it on a button press. So you press button A, and it just says 3. So that's the reading between sort of 0 and 1023. And as I'm sort of setting up stuff for a soil moisture tester, if I press button B, it gives you a little sad face, and it says too wet. So that's low resistance, so you've got too much moisture in the soil. If I turn it to the other extreme, see the graph is illuminated completely, all the LEDs. Press button A, and that should be 1023. And then if I press this button here, I might need to wait for it. It'll go back to the bar graph. Sad face again. It should be too dry because it's high resistance. So I'll just use the pot just to turn it somewhere in the center. Let's wait for the graph to come back. There's a little bit of a delay on the message there, so somewhere in the center. So between 400 and 600, it should display that it's just right. So if I press this, it just should say 478, and then go back to the graph again. The pause is a bit too long on this. And then I'll press button B. Hang on a minute. Yeah, happy face. Just right. So it just shows you in the middle there, between too wet and too dry, is ideal sort of conditions. So what I've also done as well, I've set this up with a serial monitor in Arduino IDE, and I installed the drivers for the microbit. And once again, I've got the pot here. So if I just tweak this, you can see the figures on the screen changing as that's to one extreme, so that's 3. And if I turn it up to the other way, 1023, I'll turn it down, and I've got a reading 459. So looking at the microbit, 461. Oh, it's gone to 461 now. It's stabilized a little bit. So I'll turn this around again. This is 287. And then looking at the microbit, I'll just wait for it to go back to the graph. Go on, graph. Yeah, I had to change these pauses in here. So it says 287, and that's once again the same on the serial monitor. Just looking at the make code here on the makecode.microbit.org website. Forever means this just loops around and round and round. Set moisture, which is a variable here, and then so there's moisture is just reading analog pin 0, and serial write moisture just means it's connecting by the USB, and it writes the data into the serial monitor. Plot graph of moisture up to 1023. So this is that graph which you can see here. So 1023. There you go. That's 1023. All the LEDs illuminated. If button A is pressed, then show number, and once again you're referring to that variable which is set up, which is analog read pin 0. So it just saves writing that out each time. I've got a 5-second pause here. That's way too long. That needs to be much less. And then I've got if button B is pressed, if moisture is greater than 600, then little sad face and a pause of 1 second. I've got show string. Show string means it just scrolls through the display and it just says too dry. And I've also got another if moisture is less than 400, then sad face, pause 1 second, show string too wet. And then lastly I've got another one here. There's a 5-second pause there, so I need to make that 1 second. If moisture, so what I've got here, rather than just being if moisture is greater than 400, I've got an and in there as well. So I'll go back to there, and moisture is less than 400, so it gives you that range between 400 and 600. Show image, happy face, show string, just right. So it gives you an indication. You can tweak these settings and you can put whatever messages you'd like in there. So once again, yeah, thanks for watching. It's just a simple project, just using a potentiometer and to get it to use the serial